So this, it wasn't necessarily, if you looked at the grading, it says it's out of 0 points. It's literally just a practice to see if we remembered forms. Who can remind me of what cotangent is equal to as a fraction? What over what?
1 over cosine?
Yeah, 1 over cosine.
Cotangent. You're thinking of secant.
Tangent?
Oh,
Yeah.
1 over tangent.
Yeah, 1 over tangent.
1 over tangent. What is tangent equal to? So I'll start there.
Sine over cos.
Sine over cosine. Yep. I think there's only shift there. So this is sine x over cosine of x, which means cotangent would be cosine over sine.
Okay.
Keep my subtraction. And then I'm going to do the same exact thing in the denominator. This should be skipping ahead.
Isn't it just 1 over 1? No, that would be as positive in there.
Yep, since they're not same because we have an addition and subtraction, so they're not the same terms. If it was cotangent minus tangent over cotangent minus tangent, then it would be 1. We cannot combine these since we don't have 1.
Same denominator?
We don't have the same denominator.
Way to go, Memphis.
Thank you.
So what I can do...
I'm here for you now, Memphis.
What would be my easiest common denominator?
Sine times cosine?
Sine times cosine.
Yes, sine times cosine.
Yep, so for here, I multiply by cosine. So this is step 1. This is going to be step 2. So then cosine times cosine is cosine squared of x times sine x cosine x minus, this is going to become sine squared x. So I have to multiply by sine. So sine x cosine x. Then I do the same with the denominator. So it's going to become cosine squared x over sine x cosine x plus sine squared x over sine x cosine x. Any questions so far?
No.
No.
Okay. So now that I have common denominators, it's just combining terms. So I'm going to have step 3. So this is just cosine squared x minus sine squared x over sine x cosine x. Then we have cosine squared x plus sine squared x, which is equal to what?
1.
1. Yep.
The
Pythagorean identity.
Correct. So this is Pythag. I'm actually going to switch color. I'm also going to use multiplication by reciprocals to cancel out our two denominators since they're the same. So I'll really up here be multiplying by sine x cosine x over 1. So these will cancel. Is that part clear how I did that?
Yeah.
Okay. So then all I have left is cosine squared x minus sine squared x. And if we go back to the double angle identities, that was a horrible line. So this is just equal to cosine of 2x by the double angle identities. So this is something you would be given on any assessments you have. So this isn't something you'll have to sit here and memorize. Like as soon as you see this form, you'll know, oh, I have from my paper it's cosine of 2x. Which is exactly what we wanted it to equal. So this is true. Does that help, James?
Yeah.
What part was confusing you?
I'm just not really good at, like, even when we were in school, I wasn't really that good at this.
Okay, so with these are more just complicated and dealing with the practice. Yeah. Alright, there's going to be a bunch more coming up. Today's video, I'm going to keep it a little bit shorter. There's really not a whole lot of information we need from this. This is all stuff we can derive from the double and half angles, but it's mainly important for getting more practice. So today is on, let me switch this back. This is on the product sum identities. This is 6.4. Now
Mr. Ben, that'll leave in like 5 minutes.
That's okay. This video will be online, so you can just pick up from here and you'll be good.
Okay.
My plan was to have us in 3 different groups to work together to solve all of them and just quickly combine them. Unfortunately, that's not an option. So this is going back to the sum identities. So we know that cosine of, does anyone remember what cosine of a plus b is?
Isn't it sine something?
It's cosine first.
Cosine? Oh, is it cosine x, sine x, or something like that?
So you're thinking of sine. So for cosine, it's just cosine a times cosine b.
Yeah, that's what I thought.
And then we take the opposite sign of what's inside, so it's going to be minus, and then it's the sign. So minus sine a, sine b.
Yeah, I remember doing that.
The sum identities are things we do need to know. As long as we kind of remember this form, you'll be good. Then if we had cosine of a minus b, this would be still the same structure for cosine a, cosine b, but since I have minus, it's going to be plus. Erase this little mark quickly. Okay. What we do is we're actually going to combine these 2 terms to be able to derive one of our identities, and that'll just give us the rest. So on the left, well, the terms are technically different because this is a plus b, so it'd be like having, this is essentially like we can't add x squared and x because they're different. So cosine of a plus b is different than cosine of a minus b. So this will just be cosine of a plus b plus cosine of a minus b. On the right side, I have a negative sine a, sine b, and a positive sine a, sine b, so these just cancel.
So it's 2 cosine A, cosine B.
Yep, so I'm just left with, like you said, 2 cosine a, cosine b. And then we want these in terms of our product identities. So I want cosine a times cosine b equal to something.
Isn't it 2 cosine? Oh, never mind.
Yep, yeah, we got that.
Sorry.
So we
I thought that
you're good.
I forgot that 2 applied to, like, both of them.
To both, yeah.
Yeah.
I'll put this in parentheses.
I gotcha.
So then we divide by 2 on both sides. Oh, I missed a parenthesis over here. Oof. And then we're just left with one of our identities, which is cosine of a times cosine of b is equal to half cosine a plus b plus cosine a minus b. To save ourselves time, we would have had 3 groups doing these all on the board at the same exact time. I'm just going to go scroll up to our product to sum identities. The first one we just found is cosine a cosine b is equal to half cosine a plus b plus cosine a minus b. Our second one is going to be sine times sine. So sine A times sine B. This is going to be equal to half cosine of A minus B minus cosine of A plus B. And then we currently have cosine times cosine, sine times sine, so we need sine times cosine. So we'll have sine A times cosine of B. Again, we're going to have a half. And this time we're going to have sine on the inside of the brackets. So it's going to be sine of A plus B plus sine of A minus B. That's it for the product to sums. We'll do one example to show how they can be used. But then we're just moving on to sum to product, and then we're just doing one identity with those.
I gotta go, Mr. Bennett.
Okay, take care.
Yep.
So, we're going
Can you go back
to...
so I can see the equation again? Just for a little bit.
Yeah, I'll leave it there.
Thanks.
I can actually... I believe I can pause my screen sharing. Let's see how I can do that while I write this. Okay.
Mr. Bennett.
Yeah.
So, like, if we like miss one of these, this video will be posted on your YouTube, right?
Yeah. So everything here is going to be posted on my YouTube, and every time in the class notebook, I'm going to show this afterwards to how to submit what I'm going to give you at the end of this. In the class notebook, I post all of these as well under the welcome, and then I have it's like day 1 video notes, day 2 video notes. So I'm going to show that at the end of how to like look at those. So this will also be posted as an image there, so all of the notes will be available, both in the video or in the picture form.
Okay.
I'm also going to go and put parentheses around these so we don't think that it's 1 times that. Alright, everyone good?
Yeah.
Quickly add a parenthesis. I'm going to be writing the formula down here, not to worry about it. So sine x cosine of y equal to half sine x plus y plus sine x minus y. Okay. So this is just trying to really like verify using the different letters. So I currently have sine of x times cosine of y is equal to half sine of x plus y plus sine of x minus y. I want this to be simplified, so what I do is going to be kind of an odd substitution. Since I want this in terms of a and b, I'm going to have a as x plus y and b as x minus y. Hold up. Oops. I forgot I don't actually even do any examples with the product to sum. That's right. So this is actually sum to product. My bad. I was like, this seems like the next material. So this is how we derive sum to product. These ones are not as simple as product to sum, where we just took 2 and added them together. We have to do some weird substitutions. So from here, what we need to do is add these 2 together, actually, and then subtract them as well. So I'm going to have x, I'm going to do this in a different color. So for my first one, I have x plus y equals a. I also have x minus y equals b. I'm going to add these two together. And then I'm going to do, in a different color, x plus y. That's kind of a rough to see. Over here I'm going to have x plus y equals a minus x minus y equals b. So first, x plus x is just 2x. Y plus negative y is 0. So I'm going to get 2x equals a plus b. And then I'm going to get here, so I can sub in for x. X is equal to a plus b over 2. For my red, x minus x is 0. Y minus a negative y is 2y. And then I have a minus b.
Wait, Mr. Bennett.
Yeah.
Wouldn't a equal x or something like that, and then b would just equal y?
So you're trying to do substitutions, right? By like saying a is equal to.
Yeah.
You're trying to like isolate for x and then like plug in.
I'm saying like it's cool. 'Cause, like in the other things you wrote out, it's like sine of a times cosine of b. So like, where does a equal x plus y come from?
So this is kind of math magic. In proofs, a lot of times we do very weird experimentations where you substitute something complex like x plus y for just a single letter.
Gotcha.
Because if I were to try and do like substitutions, like if I were to isolate x, so if I had x is equal to y, a minus y, and then I tried to plug it in over here, I'd have b is equal to a minus y minus y. I still have too many unknown variables, so I can't actually solve anything. So I'm still stuck with 3 variables, no matter what I do. So for this, I'm getting rid of some variables.
Okay.
I'm going to leave that there for now. Am I in pen mode? Where's my marker? So over here, I'm going to have y is equal to a minus b over 2. I can go erase this now. So now that I have, well, I have x as a plus b over 2, I have y as a minus b over 2. I can go plug all of this information into my original. So if I bring this down, I know sine a plus b over 2 times cosine a minus b over 2 is all equal to half sine of a plus sine of b. Right now we're looking at sum to product, so I want my sum to be by itself. And this kind of gets into your question as well of like the why are we doing this, is because I want my sums to be in terms of one variable, which now they are. Sine is in terms of a, sine is in terms of b.
Okay.
So if I multiply by 2 on both sides, I'm going to get sine of a plus sine of b is equal to 2 sine a plus b over 2 cosine a minus b over 2. So that's how we would go through finding each of these sum to products. Obviously, we're not going to do this for all of them. It's going to be very repetitive and really just a waste of time. So I'm going to go back up. I'm going to be writing, if you don't have this part written down, it's okay. I'm going to be writing this one up ahead. we had just found the first one, which is sine of A plus sine of B is equal to 2 sine A plus B over 2 cosine A minus B over 2. I could also have sine of A minus sine of B. I could have cosine of A plus cosine of B and cosine of A minus cosine of B. So for sine minus, it's 2 sine A minus B over 2 cosine A plus B over 2. So it just changes where the sum and subtraction signs are, just flips them. For cosine of A plus cosine of B, it's 2 cosine A plus B over 2 times cosine A minus B over 2.
It wouldn't be sine?
Nope, not for cosine of A plus cosine of B. And if we think about, if we go back even like to the double angle identities, so like sine of 2x is equal to 2 sine x cosine of x, whereas cosine of 2x is equal to cosine squared x minus sine squared x. So the operations can be different between using cosine and sine.
Okay.
So it doesn't always matter. Or like even with the when we did the sum identities, so like sine of, in parentheses, let me write this down here, sine of A plus B. So this does not take the same form as like cosine of A plus B.
Yeah.
Cosine was cosine A cosine B minus sine A sine B, whereas the sine was this was cosine A, no, sorry, cosine B sine A plus cosine A sine B. So like they'll look different depending on what you have. Generally with cosine, it's usually safe to assume cosine is going to be cosine and cosine together. And that kind of goes with the idea of like even and odd functions is how I like to think about it. So I like to think of like evens and odds as like matches. So if I have an even, I have like a negative times a negative or a positive times a positive. For odd, I always have the opposite signs. So since sine is a negative, I have opposite functions. Since cosine is even, I have the same functions.
Mm-hmm.
Cosine is even equals same. Sine is odd is different. For cosine of A minus cosine of B, this is going to give us minus 2 sine, so the 2 in front stays the same, but it's going to be the negative, and then this is going to be sine of A plus B over 2. Since it's an even function, I need the same function in the end, so it's going to be sine A minus B over 2. Any questions? Okay. If there's no questions, I'm going to move on to the last thing we're actually going to be doing for the notes. And I'm going to make my life a little bit easier right now. Let's go this way. Actually, I can do a marquee. I'm going to go hide this. So the last thing we're going to be doing is just a simple, it's not really simple, but it's just identifying the forms. So it's a small identity. I think this is right. So I have sign. Of x plus y over 2 cosine x minus y over 2. I don't know if I... I'm writing a little bit too big for myself. And then I need plus sine x minus y over 2. That's horrible. Cosine x plus y over 2. Okay. Do these look kind of familiar?
Yeah.
Yeah, to which ones? Which numbers?
I mean, that whole thing kind of looks familiar.
What numbers over here do these look familiar to? So this first one looks what most like?
Like sine a plus b, and then cosine. So it looks like 4.
So it looks like 4.
Yeah.
Except I'm missing a 2 in front.
Yeah, you're missing a 2.
I'm missing a 2 in front. So I have half of number 4.
Yes.
And then I
Is that
have...
what the other half of it is?
What does this one kind of look like?
Is it number 5?
Looks like number
Yeah.
5, yeah.
This one looks like half of number 5. Which is fine to say, so this is... Because if I had 2 times a half, well, 2 times a half, this would just give me 1, so that makes sense. So number 4 tells me that this is equal to sine of A minus sine of B. So I have half sine of A is X. Sorry, number 4 is plus sine of Y. And then this can be plus half. What does number 5 tell me? Number 5 is sine of X minus sine of Y. What would be my next step?
The other side?
So I already got this done. So I'm just simplifying.
Add them?
Can I add yet or no?
Yeah.
No, you have to multiply?
I'd have to distribute first.
Or distribute?
Or you gotta distribute the half in.
So I can distribute half sine of X plus half sine of Y plus half sine of X. And then it's going to be a minus a half sine
So it just
of
become.
Y.
Why no, it's not.
Sine x.
So what?
It would be sin x.
Yep, because we have half and a half. Do some red.
This.
So this is sine of X. And then I have half minus a half for sine of Y. So that's just plus 0 sine of Y. And that's it. That's really all we're going to cover for 6.4. It's not as prevalent, say, on your final or even within what I'll give you.
Good, because I'm not good at this stuff.
I'm not gonna
I'm going to quickly
missed
save this.
8th period today.
What?
I miss having 8th period with you every other day.
Yeah, hold on one second. I'm going to discuss that too. So I'm going to save this. This is currently in pre-calc I need to go to JPEGs. I need to make this video 3. Alright, I'm going to switch my screen sharing real quick.